Next, triad system. So in triad systems, Tautomerism arises due to 1,3 migration of hydrogen between two polyvalent atoms. Okay. So 1,3 migration of hydrogen atom takes place between two polyvalent atoms. Okay. So in triad systems, we can take Keto-Enol Tautomerism. Okay. Keto-Enol Tautomerism is one of the type in triad system. So Keto-Enol Tautomerism. So we observe 1,3 migration in Keto-Enol Tautomerism. And in Keto-Enolic Tautomerism, keto form is more stable and enol form is less stable. Okay? Why? Because in keto form, carbon double bond oxygen. So C double bond O group is present in keto form. Whereas in enolic form, COH group is there, but double bond is present in between two carbon atoms. In enolic form, double bond is present in between two carbon atoms, whereas in keto form, double bond is present in between carbon and oxygen. So bond energy of C double bond O group, that is more than that of C double bond C. Okay. So that's why more stable form, we get more stable form, that is in keto form. And enolic form, that is almost negligible in Keto-Enol Tautomerism. Okay. So why? Because what is the reason behind this? Carbon double bond O, bond energy is greater than C double bond C bond energy. Okay. So carbon double bond O, bond energy 364 kilojoules per mole. Okay. Whereas C double bond C, 254 kilojoules per mole. Okay. So due to more bond energy, we get more stable keto form when compared with the enol form. So keto form is always more stable than that of enolic form. Okay. For example, so if we take acetaldehyde. Okay. So it is in dynamic equilibrium with vinyl alcohol. Okay. And acetaldehyde is keto form and vinyl alcohol is enolic form. Vinyl alcohol, enolic form. So here 1, 2, 3. So 3 polyvalent atoms are there. And migration of hydrogen takes place in between first polyvalent atom and third polyvalent atom. So hydrogen from first polyvalent atom migrates towards third polyvalent atom. So 1,3 migration that takes place in acetaldehyde. So due to 1,3 migration, we get a new compound which is vinyl alcohol. Okay. So we get enolic form. So here keto form, this is 100% keto form. But enolic form is negligible. Negligible. Okay. And keto form is 100%. Enolic form is negligible. And one more example. For example, acetone is there. Acetone. Okay. So it is in dynamic equilibrium with enolic form. So acetone, keto form, this is more stable. This is in dynamic equilibrium with prop 1 in 2-vol. Okay, enolic form. Prop 1 in 2-vol. Acetone, keto form. And this is prop. 3 carbons are there. Root word is prop. Unsaturation is present at first carbon, 1 in. And second carbon alcoholic group is there. So 2-vol. Okay. Prop 1 in 2-vol. So this is enolic form. Enolic form. Here we get 99.78% keto form. Okay. 99.78% keto form. Whereas enolic form, this is negligible. And here also 1,3 migration takes place. 1,3 migration. So this is 1, 2, 3. So hydrogen from first polyvalent atom migrates towards the third polyvalent atom. And we get enolic form like this. Okay. And here also keto form is more stable because C double bond O bond energy is more than that of C double bond C bond energy. And one more example in cyclic compounds. Next, in cyclic compounds. For example, if you take cyclohexanone, keto form. Okay? Cyclohexanone. And it is in dynamic equilibrium with enol form. Okay? So, enol form. This is enol form. So, this is cyclohex. 1 in and 1-ol. Unsaturation takes place at first carbon, present at first carbon, and also OH group, that is also present at first carbon. Okay? Cyclohex 1 in 1-ol. Okay? Enolic form. Cyclohex 1 in 1-ol. So this is enolic form. And this is keto form. Keto form, enolic form. And here we get 98.8% keto form and 1.2% enolic form. Enolic form is always negligible. Okay. So 98.8% keto form and 1.2% of enolic form. Here also we observe 1,3 migration of proton. Okay. So here carbon linked with 2 hydrogen atoms. Okay. Starting from here 1, 2, 3. Okay. So from first polyvalent atom, hydrogen migrates towards the third polyvalent atom. Okay. And we get enolic form. Cyclohex 1 in 1-ol, which is enolic form. And cyclohexanone is keto form, which is more stable form, and more percentage of keto form is formed here. Okay. Then conditions for tautomerism. So some important conditions that are used to takes place during tautomerism. So to exhibit tautomerism, compound must contain electron withdrawing groups. Okay. So compounds should have electron withdrawing groups. So first condition is to exhibit tautomerism. Compounds should have electron withdrawing groups. For example, electron withdrawing group, cyano group, nitro group, okay, carbonyl group. All these are electron withdrawing groups. Okay. Cyano, nitro and carbonyl groups. Okay. So these are electron withdrawing groups. Next, one more condition. So to exhibit tautomerism, that compound must contain at least one alpha hydrogen atom. Okay. Compound must contain at least one alpha hydrogen atom. So that is second condition. Okay. Compound must contain at least one alpha hydrogen atom. For example, carbonyl compounds and nitro compounds. So in nitro compounds, that alpha hydrogen atom is also called as active hydrogen atom. Active hydrogen atom. So these are the important conditions to exhibit tautomerism. Okay.